Really good, Paul. And let's welcome Ken Koedinger. He is the Hillman Professor of Metals Program and Metals Program Director at Carnegie Mellon. And he's going to talk to us about Opportunities Matter, hybrid human-computer tutoring towards educational equity.
Okay, pulling up my slides here. I'm not going to talk about the CLE framework, which Chris indirectly alluded to, and I put it in the chat in case you are interested in that. But I'm going to talk about work related to two papers that we recently put out, and I think those papers will be available on the web materials. Well, I'm going to start my timer, make sure I'm on time here. This is, I want to talk briefly about some past evidence that AI tutors work, but then suggest how we can use them as research tools to move us forward toward particularly understanding how to bring human tutors to bear on helping with motivational issues to reach all students. So starting with this, we, with NSF support, actually starting in the late 80s, but a lot of work in the 1990s, developed these AI-based intelligent tutoring systems based on cognitive science. We call them cognitive tutors. We spun off a company in 1998. They've been used by millions of students and been evaluated many times. This 2013 reports one of the largest randomized field trials of ed tech, the largest I know of, 140 schools, 70 randomly assigned to use cognitive tutor algebra, so it's full course. The AI tutor used roughly 2 days a week. Text materials were developed, teacher professional development. This graph shows that in the second year of implementation, importantly, the students at those 70 schools using the cognitive tutor algebra course gained about twice as much over the school year as students in the other 70 schools using their traditional algebra course. But there's so much more we can do. And using data from systems like this that have been fielded to advance science is one example I want to give. And then doing even better, especially to reach more students, all students. So on the scientific side, we wanted to address this topic, and it relates to assessing, in this case, assessing students' learning rate. Do different students learn at different rates? And through NSF's funding of the Learn Lab Science of Learning Center, we amassed lots of data sets. There are now 4,000 in Learn Lab's data shop, but we took 27 of them that met particular criteria and built a logistic regression growth models. Just don't have time to go into the details, but basically we're trying to assess for each student I here, predict their probability of success by estimating initial knowledge, and then how much they improve in their success with each successive opportunity to practice. And we do that through logistic regression. The log odds transformation would be important to a graph I'm going to show you in a second. And if you want fuller technical details, there is the equation. I'm happy to take questions about that. You can look at the paper. But here was our surprising result. Like I wanted to do this to find the students who were learning faster than others, and then we're going to try to figure out what learning skills they have. What these graphs show is across 4 of the 27 data sets are learning curves that have been transformed in the y-axis here to display performance. These labels are proportion correct, but they're displayed on the log odds scale, so that makes the lines straight. But what's striking is how parallel they are, which indicates that for each opportunity to practice, students are pretty similar, no matter whether they start off low or high in the rate at which they learn. There's more variability in this data set, but generally these 3 are pretty representative of all the data sets. The other striking thing about this is there's much greater variability in initial performance. And these are educational technologies that are embedded in real courses, right? So all the students in these studies met the prerequisites of the course, right? They're nominally, starting off the same, right? But no, they're quite a bit different, 88 to 27% correct here 73 to 12% correct here at the beginning, right? But very similar in rate. So good news, when students get practice opportunities, they seem to learn, especially these high quality, deliberate practice where there's this AI tutor available to provide feedback. The not so good news is that many students are not getting enough opportunities. And we see this, for example, in dosage graphs in ed tech, where total time zeros on the x-axis, and this is a measure of performance, how many sections were mastered. There's too many students in the lower left corner here. But what these graphs illustrate is, again, that when students get opportunities to learn, they learn. As somebody said earlier today, you got to write to get better at writing. You got to do math to get better at math. And but if you're not, that's where these achievement gaps we see racially and economically may be arising essentially from opportunity gaps. So what can we do about it? Well, as many of you know, I started my career actually in AI, but then cognitive psychology. But there's so much in social psychology these days about enhancing student motivation. If we can help students support them, motivate them to put in more opportunities, we can move them up this curve. And there's lots of different constructs here. This is another need for a component-based taxonomy, right? There's not just one kind of motivation. There's growth mindset. There's feelings of belonging. There are, why is this math important to me in my future? Am I in a healthy relationship with my support systems for learning? Do I feel stereotype threat? Really rich opportunities there. So we've been using that to, in an approach, a hybrid human-computer tutoring approach that I want to tell you about, and both some achievements, but some prospects for the future. It's called Personalized Learning Squared, or we use the acronym PLUS. AI tutors are particularly good at supporting math learning. They're not so great if students don't use them. Students don't learn from them, right? We need other ways to help motivate students to engage in doing math, and human tutors have complementary strengths in supporting motivation. So we want to put those things together. We've been working with mostly at this point after school organizations like the three listed here, where tutors and students work together. They go back and forth in face-to-face activities and online practice with the tutoring systems. And they're supported by the PLUS app, which is a web-based app. It's kind of like a Fitbit for learning, where the tutors and the students they're tutoring can monitor their ongoing effort and progress. They can set weekly effort goals, like I'm going to do 50 math problems a week. And then here, this is Alex, and he's got a set of students that he's working with. And this shows him which students are not missing their effort goals or are hitting them. And he can remediate based on this feedback and have discussions with students, especially around these motivational issues. And at the same time, we are providing lots of resources that initially in this project were more static resources that we found on the web, but we've been increasingly making them into essentially tutors for tutors, scenario-based practice activities on especially these motivational issues. Like, one of the ideas in growth mindset is set up through a scenario where a student just succeeded in a task. How do you respond? And essentially this is framing an issue of whether praise from a student should be about achievement or effort. And if you know that literature, the perhaps non-obvious result there is you should not praise achievement, you should praise effort. And this goes to things we heard earlier today about the importance of trying and failing. That's where learning comes from. So we've had an opportunity to do a quasi-experimental evaluation of this approach so far, and there's a little bit of methodological illustration here of a propensity matching approach where we found students at these same 3 urban schools that matched the demographics and the prior achievement of the students who were in our after-school program. So we had 70 students who participated in the program. There were about 500 students that were in these same schools at about the same grade levels from which we could choose from to build a control condition. These white dots show on the various dimensions where that whole group was. And through propensity matching, we get a subset of 300 students that are this absolute standardized difference is how much they're different from the treatment condition. So that control essentially is selected to eliminate differences. Notice there's a very highly Black and brown group of students that were purposely selected to be part of this effort in urban schools. So what did we find? So we're using the NWEA map tests that the schools use diagnostically. We had in the year 2020, during the pandemic, actually started in the fall and winter, essentially those test scores as a pre-test, and then the subsequent fall and winter of 2020, we had post-tests, and these are showing the difference for that match control. So they gained on that test 3.6 RIT points, whereas the treatment gained 6.8. Essentially, the treatment doubled achievement over the school year relative to this matched control. As a kind of check that our propensity matching worked, the unmatched control does score higher, though there's a somewhat better, more advantaged selection of students, but not quite as good as the national average on this test. But our treatment students actually outperform the national average as well, even though they're in a pretty low-income urban school district. So this looks quite promising. Another method we use to help us make sure or reduce the risk of having selection effects here, like, are the students attending these after-school programs just better, generally better students? If so, we'd expect them to show better reading test score gains. So we have this control for that sampling issue that shows indeed there's not a significant gain for the ready-to-learn participants or treatment participants on the reading NWEA test relative to the control. So I've got about 3 minutes to say a little bit about ideas going forward in the future. These are motivated by the idea that tutoring is being shown historically through computer-based tutors, but especially recently through human tutoring to be super powerful. But the challenge is to get it to the right students and do it at scale. And our solution is to create superhuman tutors through training, but also through technology that can essentially allow our tutors to see through classroom walls and zoom into the classroom at just the right moment to help students out. I'm going to focus on this level 2 tutoring, but I want to contrast it with 2 other approaches that are out there. What we just saw and what others have been doing are these scheduled extra sessions, and they're really powerful for building relationships, confidence for students as well as competence. They are highly costly though, but they have had high impact. Saga Education, in addition to our results, are indications of that high impact. At the other extreme, for students who are motivated enough, they can go online and get a tutor now through Upchieve and other approaches. So this is pretty low cost because they're volunteer tutors, but the impact evidence really isn't quite there yet. Schoolhouse is another one of them. The other issue is that it's not reaching all students. So can we find a way to get tutors to all students in school? And what we're trying to do is inspired by, if you were here earlier and you heard Jennifer talking about Lumalo, it's inspired by that dashboard idea, and I'll show you that in a second. But this is more within range for schools. We estimate that we could get tutoring costs below $1,000, maybe even $500 per students. And it might even have higher impact. There's the 3x gain shown by this Lumalo approach. And if you were here, you saw this picture of Ken Holstein, Vincent Alave, Bruce McLaren built this system where the teacher had a head-mounted display in which they could see these augmented displays over students' heads of these struggle detectors. But imagine instead, or in addition, that remote tutors are seeing a similar kind of display whereby they can find which students are gaming the system or unproductively struggling, and jump in and help this student or help that student or help this student. What's super powerful about this and was shown in Ken Holstein's data is that the students who aren't typically raising their hands are the ones who are getting the most help. The ones with their lower pre-assessments who really need it get much more help through this. So I think that's really promising. So in 40 seconds, I'll summarize here. AI tutors are being shown to work in favorable conditions like these tutors and other, like the Open Learning Initiative online courses, educational games that are well designed. In those favorable learning conditions, the evidence seems to suggest all students can learn, but there are inequities in the starting point. If we can get more human tutoring into the mix, it seems like there's some real potential for making a big impact, maybe doubling schools. And if we can do this through remote tutoring that's dashboard initiated, we can especially get to all students with this kind of help. That's it. Thank you.
Great. Great. Thank you very much, Ken. Chad, do you have a question? Chad, you have your hand up?
I was clapping.
Oh, I'm sorry, of course. Yes, very good. I do have one question. You mentioned, Ken, that you're going to look at these rich opportunities to provide growth mindset comments, get students to feel like they belong into relationships and away from stereotype threat. But am I accurate in saying you did not mention doing any of that currently?
Oh, that's what, well, sorry that I packed a lot in here, but that's what this tutoring was about. And that example of growth mindset I gave. There are a whole set of resources in the Plus app here on building relationships, supporting effort, and within these resources are distinctions. There's growth mindset activities like this one. There's utility value.
But is it sort of text that's provided? Suggestions, or does the AI tutor actually do that to find out?
No. What we're doing is we're taking volunteer tutors like undergrads at CMU and Pitt, and we're training them on these techniques through scenario-based practice environments. Okay. You're tutoring a student who just succeeded in a task. How are you gonna praise them?
Got it.
And they respond, and then we give them feedback, and we point them to a summary of Carol Dweck's work on growth mindset. But it's very much of a learn by doing approach, and then they get a second scenario, analogous scenario, to demonstrate their competence. And we see in 15 minutes for these these focused kinds of activities, we can get growth in their expertise, at least within these scenarios. Next question we haven't addressed yet is, does that learning within these scenarios transfer to the real world of tutoring? And we're collecting data now to try to see if that's the validity question of all assessments. Does the sequestered scenario-based approach transfer to the real world? And so that's something definitely we will have answers to in the next 3 years.
Got it. Okay, great. So that does provide perhaps a project, right? A 3-year project that we were talking about.
Yep.
Great. I hope you fill out that form.